All right, welcome to The Explainer. Today, we're going to dig into a pretty massive shift happening in AI development, and we're going to tear down a challenger platform that thinks it has the answer.
You see that quote? As useful as a screen door on a submarine. That's how some folks are describing the classic request-response model. For years, that was the absolute bedrock of the serverless world, but it's hitting a wall. It's just proving to be a huge bottleneck for this new wave of AI agents that need memory, they need state, and most of all, they need to be fast.
So that's the big question, right? How do we build AI that actually works out here, in the real world? Well, a pretty deep technical analysis of Cloudflare's developer platform suggests an answer. You have to rebuild the entire stack from the ground up, and you have to do it right at the edge. Let's dig in.
Okay, so here's the plan. First, we're going to take a quick look at why the old way of doing things, these stateless functions sitting in some faraway data center, why that's just not cutting it for these new, persistent, autonomous AI systems.
Then we're going to unpack the core idea behind Cloudflare's big bet, moving everything, the compute, the state, the memory, as physically close to the user as you can possibly get, right to their doorstep.
And finally, we'll get our hands dirty and break down the actual tools in Cloudflare's toolkit. We'll see how this all really comes together to build these agentic systems.
First up, let's talk compute. So instead of just grabbing some generic Python servers off the shelf, Cloudflare went and built a custom engine from scratch. It's called Infire, and it's written in Rust, which is a big deal, and it's specifically engineered to serve these massive AI models right at the edge without completely breaking the bank.
Now this is where it gets really interesting. This is Infire's secret sauce for speed. It uses a few key tricks. First, it uses these monolithic CUDA graphs. Think of it like bundling a ton of tiny little GPU commands into one big, super fast one. Second, it uses something called paged KV caching for way smarter memory management. And third, because it's built in Rust, it completely bypasses a lot of Python's performance issues. So what's the result of all that? Well, you get inference that's up to 7% faster, with a staggering 82% lower CPU usage compared to some of the big open source players.
And you know that classic serverless problem, right? The dreaded cold start? Well, they have a really clever way of tackling that too. They call it the shard and conquer routing strategy. Basically, it maximizes the chance that the environment you need is already warmed up and ready to go. And they're claiming a 99.99% warm request rate, which, wow, that's a huge deal. But honestly, the biggest game changer here might be how they handle memory. This is a technology called durable objects, and what it does is bring the idea of state back to serverless. This is so elegant because it solves the whole agent memory problem without you having to spin up and manage a whole separate complex thing like a Redis cluster.
The best way to think about a durable object is like it's its own tiny, persistent little microserver. It's got its own database, a SQLite database, built right in for practically zero latency state changes. It can handle thousands of real-time WebSocket connections at once. And this is the really cool part. It has a built-in alarm, so it can wake itself up and do things later. For truly autonomous agents, this is absolutely essential.
And okay, for all the big stuff, like your training data or model weights, there's R2, which is their object storage. But the headline here, the thing that gets major AI companies like Character.ai so excited, is the promise of zero-egress fees. That's a massive deal. It basically breaks the vendor lock-in that traps your data inside a single cloud provider.
Okay, so the tools sound great on paper, but how do they actually perform against the competition? Let's throw Cloudflare into the ring against the hyperscalers and some of the other specialized players out there. So when you put them up against the big guys, you really see a story of trade-offs. I mean, if you need pure face-melting speed for things like real-time voice AI, Grok and their LPUs are the undisputed king, no question. But Cloudflare carves out this really unique spot with its predictable pricing and, crucially, its ability to keep data at the edge. And that is a huge win for anyone worried about data sovereignty and privacy.
But let's move beyond those high-level comparisons for a second. What about just raw head-to-head compute power? Well, a developer recently ran a benchmark putting Cloudflare Workers directly against a big competitor for cell edge functions on a task that was pure CPU number crunching.
And yeah, this chart pretty much says it all. The results are pretty telling. In this particular test, Cloudflare's average execution time wasn't just a little faster. It was over 3 times faster than Vercel's. So that really challenges the whole narrative that their compute performance might be lagging.
Performance is obviously critical. But let's be real.
For any technical decision maker, it almost always comes down to the bottom line. So, let's talk about the money.
I want you to just let this number sink in for a second. 83%. That's not a typo. That is the total cloud bill reduction that an observability company called Baseleam saw after they moved their entire infrastructure from AWS over to Cloudflare. So how on earth did they do that? Let's break it down. That crazy 96% drop in compute costs comes from a really fundamental difference in how they bill you. See, traditional serverless charges you for wall clock time. That includes all the time your function is just sitting there, waiting for a database or an API. Cloudflare? They only charge you for the active CPU time, the milliseconds your code is actually running. For AI orchestration workloads, which do a lot of waiting, that's a massive structural advantage.
So what should you, the architect, the developer, the person who actually has to build this stuff, take away from all this? Look, Cloudflare isn't a silver bullet for every single problem, but it is a seriously powerful new option in your toolkit. This decision matrix kind of lays it all out. The right tool really depends on the job. If you're building a stateful chat agent for your SaaS product, going full-stack Cloudflare is incredibly compelling. But if you're building a really complex enterprise RAG system, or that real-time voice app we talked about, you might use Cloudflare Workers as the central orchestrator, but then call out to best-in-class services like Pinecone or Grok for their specialized horsepower.
And that's really the crucial point here. Cloudflare has built this vertically integrated platform that feels purpose-built for this new era of AI agents. But to really get the most out of it, you have to be willing to rethink some of the old patterns we've all been relying on for years.
That's the real question this new architecture is asking all of us. Are you still thinking in terms of servers and databases, or are you ready to start thinking in distributed objects and event streams? Because answering that question is probably going to define how we build the next generation of applications. Keep your stick on the ice.